Okay, now we are discussing about P block elements. In P block elements, oxoacids. So in previous class, the oxoacids we discussed. Now we will go to discuss about structures. So nitrogen oxoacids. See, already we seen HNO, HNO2, HNO3, HNO4. So first two are nitrous. So that is hyponitrous, nitrous, nitric, peroxynitric acid. Say acid that it forms more than one structure. So HNO. So HNO, hyponitrous acid. So nitrogen, one lone pair, three single electrons. So one O and one H. So nitrogen, lone pair, 1, 2, 3, OH. See, the central atom which has less number of electrons has more stability. So compared to this, this is unstable. So that's why this is a stable one, this is a unstable one. So two sigma bonds, one lone pair. So 2 plus 1, 3. 3 means sp2. One lone pair is there. So that's why you are getting a V shape. So bond angle is less than 120. Next, HNO2, nitrous acid. So nitrous acid also, as means more than one structure. So you are getting 2. So this is unstable, this is a stable one. So here 3 sigma bonds, 0 lone pairs, 3 sp2. The shape is without lone pair. So trigonal planar, bond angle is 120 degrees. So one OH group is coming. So that's why it is monobasic acid. So monobasic acid, you are getting one salt. So that salt name is NaNO2. So instead of hydrogen, active hydrogen, you put metal. So you are getting the salt. So NaNO2, sodium nitrite. So star means acid. Acid gives ITE salt. Without star you called as ic. So that you are getting ATE salt. So As is giving more than one structure, ic is giving only one structure. Now you think about HNO3. So HNO3, that is nitric acid. So here only one structure is possible. So instead of H, you write down OH. So only one structure. So that is 3 sigma bonds, 0 lone pairs, 3 means sp2, trigonal planar, 120. One OH is there. So that's why it is monobasic acid. So monobasic acid means it gives one salt. So salt means active hydrogen replaced with metal. So NaNO3, sodium nitrate, that name. Next, peroxynitric acid, HNO4. So instead of this H, you can write OOH. So peroxy bond, O single bond, O. So same manner, but no need to think about salt. Actually peroxy bond only unstable. So that's why same thing. 3 sigma bonds, 0 lone pairs, 3 sp2, trigonal planar, 120 degree bond angle. Next, phosphorus oxoacids. So already we seen once again H3PO2, H3PO3, H3PO4, H3PO5. Next HPO2, HPO3. Next H4P2O5, H4P2O6, H4P2O7. See, this is hypophosphorus. These two are orthophosphorus, orthophosphoric. This is peroxyphosphoric. These two are meta. HPO2 metaphosphorus. HPO3 metaphosphoric. So this is pyro. Pyrophosphorus. Next hypophosphoric. Next again pyrophosphoric. If you see the structures, H3PO2, so it is us acid. More than one structure is possible. So phosphorus 1, 2, 3, 4, 5. So here, so us means minimum one hydrogen directly connected to center. So one OH, two hydrogens. Otherwise, phosphorus 1, 2, 3, 4, 5. So one OH, second OH, third. See, central atom, all electrons are utilized. So that's why this is stable. So here pair is there. So that's why it is unstable. So here 1 sigma, second sigma, third 4 sigma. So 4 sigma, 0 lone pairs. So the number is 4. 4 means sp3. So without lone pair, structure is a tetrahedral. Bond angle is nearer to 109 degrees 28 minutes. Only one OH is there. So that's why it is monobasic acid. So that unstable is two OHs are there. So it is dibasic. Dibasic is unstable. Monobasic is more stable. Next, H3PO3. So that is orthophosphorus acid. So here you write, instead of hydrogen you put one OH. So here unstable is 3 OHs. Stable one is a dibasic acid. So unstable one is a tribasic acid. So here you are getting 2 salts. 3 salts also possible, that is unstable. So same, lone pair is not there. Same structure only possible. Next, H3PO4. So that is a phosphoric acid. So you are getting only one structure. So Ic acid is giving only one structure. So that is, instead of H, you write down OH. So this is what? Tribasic acid. You are getting 3 salts. So what are the 3 salts means? NaH2PO4. Sodium dihydrogen phosphate. Sodium hydrogen phosphate. Sodium phosphate. So active hydrogens are replaced with any metal. So you are getting the salts. So that is H3PO4. Next, H3PO5. So that means peroxy bond. So one OH, you write down OOH. So that is. So no need to think about salts because of the compound itself only unstable. So these are the structures. Same structure, hybridization, bond angle, everything is the same. Next, HPO2. Next, HPO2, this is us acid. More than one structure is possible. So phosphorus 1, 2, 3, 4, 5. So one O, second OH. Next, phosphorus 1, 2, 3, 4, 5. One OH. So here all electrons are utilized. So that's why it is stable. This is unstable. So here there is no OH group. So that's why it is no basic acid. But unstable compound is OH. So that means monobasic acid. So one salt you will get. So here 1 sigma, second sigma, 3 sigma. So 3 sigma, 0 lone pairs. Number is 3. 3 means what? sp2. So trigonal planar. Bond angle is 120. Next, HPO3. So it is metaphosphoric acid. So you put here OH. So this is monobasic acid. Only one structure is possible. This is monobasic acid. So that is NaPO3. So you can write as sodium metaphosphate. You are getting. Next, H4P2O5 onwards. So these are 2 phosphorus you take separately. So H4P2O5. So it is a pyro phosphorus. Pyro means you remember. So between two phosphorus, one oxygen will be present. So pyro means you must remember the point. Between two phosphorus, one oxygen. Next it is acid. Acid means minimum one hydrogen directly connected to center. So H4P2O5. So here it is a stable one. Another one also unstable compound is forming, so leave that one. So here the phosphorus hybridization, one sigma, second sigma, third, fourth. So fourth means sp3 tetrahedral. Here also sp3 tetrahedral. Next H4P2O6. H4P2O6. It is ic acid. So there is no oxygen in this. So you can write O6 OH here, OH here also OH OH. Same thing, sp3 tetrahedral, sp3 tetrahedral. So two OHs here, two OHs. So this is what tetra basic acid. So you are getting four salts. So how many basic acid? That number of salts you are getting. Next, pyrophosphoric acid H4P2O7. So one more oxygen you add. Pyro means in between two phosphorus you take oxygen. So this is also tetra basic acid. So that is four salts are available. So one sigma, second sigma, third sigma, four sigma, sp3 tetrahedral. Here also phosphorus sp3 tetrahedral structure. Next, we will discuss about sulfur oxoacids. See, already we seen what are that? H2SO3 sulfurous, H2SO4 sulfuric, H2SO5 peroxymonosulfuric, you called as a Konnur acid. Next, H2S2O2, H2S2O3, H2S2O4, H2S2O5, H2S2O6, H2S2O7, H2S2O8. In last class also we seen all those things. So this is a thiosulfurous, thiosulfuric, ditiosulfurous, pyrosulfurous. Next, ditiosulfuric, pyrosulfuric. So famous name is oleum. Next, peroxydisulfuric acid. So you called as Marshall's acid. Already in last class we discussed all those things. Now we see the structures. H2SO3. It is S acid. So sulfur, sixth group. You write down 6 electrons. S acid, minimum one hydrogen directly connected to center. Next. So another structure, as means another structure also possible. So you can write as OH double bond O. So here all electrons are utilized. So that's why it is stable. It is less stable. So here mono OH, mono basic acid. This is a dibasic acid. Here one salt, here two salts you will get. How many sigma bonds? One sigma, second sigma, third sigma, four sigma. So 4 sigma, 0 lone pairs. So that's why 4. 4 means sp3. So tetrahedral. Bond angle nearer to 109 degrees, 28 minutes. So this is monobasic acid, that is a dibasic acid. Next, H2SO4, sulfuric acid. So you are getting only one structure. So ic acid means no hydrogen directly connected to center. So that's why you are getting a dibasic acid. So here 4 sigma bonds, 0 lone pairs. Same thing. Structure is sp3 tetrahedral, 109 degrees, 28. So you are getting NaHSO4, sodium bisulfate, Na2SO4, sodium sulfate. So active hydrogens replaced with metal, you are getting salts. Two OHs are there, so you called as dibasic acid, means two salts you are getting. So you are getting two salts. So what are that means? These are. Next, H2SO5. So Konnur's acid, the name itself, peroxy is there. So one OOH. So peroxy, sulfuric acid. So actually peroxy is unstable. So that's why. So no need to think about that salts and all those things. Next. So this is thio. Thio, dithio. Next pyro. Next again dithio. Next pyro. So pyro famous only oleum here. Next H2S2O2. H2S2O2, this is sulfurous. More than one structure, that structure is unstable. So leave that one. So here this is very very important because of here S double bond S structure will come. Dithio means S single bond S. Pyro means SOS. Dithio S single bond S. Pyro SOS. Here Karos SOOH. Marshall SOOS. So direct questions in your entrance. Which of the following S double bond S? Which of the following S bond? Which of the following SOS bond? Which of the following SOOH bond? Which of the following has SOOS bond? Like that they will ask questions. Here, sulfur 1, 2, 3, 4, 5, 6. So S double bond S you remember. Next 1 O. Next OH and H. It is us acid. Us acid means minimum one hydrogen directly connected to center. So another structure also possible, that is unstable. So leave that one. One OH is there. So that's why monobasic acid. It gives one salt only. So structure means 1 sigma, 2nd sigma, 3rd sigma, 4 sigma. 4 sigma, 0 lone pairs. So the number is 4. 4 means what? sp3, tetrahedral. Bond angle 109 degrees to 28 minutes, nearer to. Next, H2S2O3. So it is ic acid. Ic acid means no hydrogen directly connected to center. So you are getting a dibasic acid. So the same structure. So two salts you are getting, but Na2S2O3. So you called as sodium thiosulfate. So the famous name is hypo. So one salt. Na2S2O3. Another salt is NaHS2O3. So that is another name. Sodium hydrogen thiosulfate. This is sodium thiosulfate. The famous name is hypo. Next. From here onwards, you can write two sulfurs separate manner. H2S2O4. So two sulfurs you take 1, 2, 3, 4, 5, 6 electrons. Another sulfur you take 1, 2, 3, 4, 5, 6. Next, thio. Thio is there means us acid. Here us acid means compulsory you take one hydrogen directly connected to center. Next, remaining oxygens you adjust. One oxygen, second oxygen, third oxygen, fourth oxygen. So H2 over S2 is over next to 4 oxygens. So directly you connect. So that is over. See this one. 1 sigma, 2nd sigma, 3rd sigma, 4th sigma. So that's why it is sp3 tetrahedral. This is also sp3 tetrahedral. Next pyro. H2S2O5 pyro. So pyrosulfuric. Pyrosulfurous. So here in between two you put oxygen. So as acid, more than one structure is possible, but coming is what? Unstable. Next, H2S2O6. So this is what? Dithio, sulfuric. Sulfuric means no hydrogen directly connected to center. Next, this is a straight bond. H2S2O6. Two OHs are there. So that's why it is a dibasic acid. One sigma, second sigma, third sigma, fourth sigma. sp3 tetrahedral. Same that structure also. Next, H2S2O7. H2S2O7, the famous name is oleum. Otherwise, fuming sulfuric acid. So otherwise, next pyro sulfuric acid. Pyro means in between these two sulfurs you put oxygen. So that is H2S2O7. So here also two OHs are there. So that's why it is dibasic acid. Dibasic acid means, so you are getting two salts. Next, H2S2O8. That is a peroxy bond. So peroxy bond in between two sulfurs. So that is peroxy disulfuric acid. The famous name is Marshall's acid. So here also same sp3 tetrahedral dibasic acid, two salts you are getting. But peroxy is unstable. So no need to think about salts. If possible also, but unstable. Next, chlorine oxoacids. So similar to nitrogen only, HClO, HClO2, HClO3, HClO4. Star means us, without star is Hic. So this is hypochlorous, chloric, per. See, perchloric. Previous what HNO4 means peroxynitric acid, but here you write perchloric acid. So HClO. So it is as acid, more than one structure. Chlorine, you write 4, 5, 6, 7. As acid means minimum. One is a hydrogen, another double bond. So another possible structure. So chlorine 1, 2, 3, 4, 5, 6, 7. So 1 OH. So this is a stable one. This is unstable. So but one OH is there. So that's why the unstable one is monobasic acid. It can form salt, but it can't form salt because of OH is not there. But structure you see means 1 sigma, second sigma, 2 lone pairs. So 2 sigma bonds, 2 lone pairs. That number is 4. That is sp3 V shape. Bond angle is nearer to 104 degrees. Next, HClO2. So it is also as acid. One more oxygen you add. Here also one more oxygen. So this is not showing oxoacid, means that salt. But here one OH is there. It will show the salt. But same feature. But what happens one lone pair? 3 sigma bonds, 1 lone pair, 4. This is sp3. Same only. The shape is pyramid. Shape become as a pyramid. Bond angle is nearer to 107 degrees. Next, HClO3. HClO3. This is ic acid, chloric acid. No hydrogen directly connected to center, and only one structure is possible. So ic means only one structure is possible. As means more than one structure. So one OH is there. So that's why it is what? Monobasic acid. So monobasic acid means it gives one salt. What is the salt means? Active hydrogen replaced with any metal. NaClO3. So as acid gives what? As acid we are showing with star, and its salt is ITE salt. Without star means ic, that shows ATE salt. So this is what chloric acid. So that's why sodium chlorate, the name. Next, last one, HClO4. So this is what perchloric acid. One more oxygen you add. So here, so 4 sigma bonds. 4 sigma bonds, 0 lone pairs. So number is 4, sp3. Structure is what? Tetrahedral. Bond angle is nearer to 109 degrees, so 28 minutes. So here also one OH is there, monobasic acid, one salt. So that is NaClO4. So your name is sodium perchlorate. You will get.